Today I'm going to be presenting the design of a restoration site at the outlet of our water reclamation facility and focus on the framework used to select the final design for our restoration site. The Water Authority operates the Southside Water Reclamation Plant, which releases about 55 million gallons per day of effluent to the Rio Grande below the Rio Bravo Bridge in the South Valley. Here you can see it's to the north and to the south, it's abutted by two Army Corps of Engineer restoration sites, and the area in the hatched outline was the area of consideration for our restoration site. In 2020, the Water Authority solicited Hazen and Sawyer to evaluate design concepts for our restoration site at the Outfall. In 2022, we signed a contract for the project to begin go into design phase. And in 2023, in July, we selected the final design for our restoration site, which is what I'll be presenting and talking through that framework of the design process and selection. So to begin selection of our restoration site to restore function to the riparian system surrounding our outfall channel, we began by identifying issues with the site currently. These photos show the current site conditions at the outfall channel. So if you guys take a moment to think about if you had the opportunity to restore this, what would you do? So just take like a moment to gaze. All right. When we did this exercise, we identified the following issues to address in our restoration site design. One is that we have jetty jacks that prevent lateral migration of the channel and pose a fire risk to the bosque. We also have utility lines in the area that we have to consider. Additionally, there's a lack of mixing between the Rio Grande turbid waters and the SWRP Outfall effluent. You can see in this middle photo that dark section is the effluent waters, and it's not mixing effectively with the Rio Grande turbid waters. Additionally, in this last photo, it was taken May 8th, and the flows at this time were about 4,800 CFS, and it's not overbanking. So that, and there's a high density of non-native species on site. It's supposed to play a video, but it's not. So what you would see in the video is that there's a lack of mixing of the waters. There's deep incision at that bank. The bank height is at like over 5 feet in this area. And this prevents the river from connecting to the floodplain in this localized area. So from this, we came up with project objectives. Following the site inventory, we identified 3 key objectives that we used for planning the design of our project. This includes making improvements to the surrounding area to benefit water quality, facilitating public access to this area, and creating additional Rio Grande silvery minnow habitat. How we approached this first objective for improving water quality in the surrounding outfall, we started with assessing the site conditions. To do this, we performed a geotechnical investigation, which characterized the soil and its chemical properties, as well as the local depth to groundwater. We calculated the consequences of sediment to water quality by calculating erosion and bank stress at this site. So the main idea being that we took baseline conditions before we assessed how we could improve this area. Okay, once the current site conditions were better understood in terms of sediment and nutrient loading, we calculated the mass reduction of sediment and nutrients to the river by the application of several restoration techniques, including core matting, soil encapsulated lifts, root rod revetments, and launchable stone key in the area. And we found that with these implemented structures, we could reduce suspended sediments in the area by 62.8 tons per year, total nitrogen by 16.3 pounds per year, and total phosphorus by 11.9 pounds per year. This means that with our current design that we could achieve our water quality improvements that we sought to. Our second project objective was to facilitate public access to the site. The site's actually already pretty well accessed in terms of a fishing location, and we sought to maintain this while also increasing the formalized trails in the area and river access points, while conversely limiting the social trails in the area, especially to the two ecologically sensitive areas to the north and south, since those are two existing restoration sites. And the one to the north actually has potentially suitable swivel habitat that we identified. The conceptual trail access plan developed for the project meets the goals while allowing expansion to be incorporated into the future. So this public access plan includes educational signage and connection to educational opportunities that will be implemented in the future. So this is more of a tiered plan. And the connection to the educational opportunities, the Water Authority actually has an educational program that exists already, which gives tours at the reclamation facility, and this outfall restoration project would be incorporated into that educational opportunity. Our third and last objective is to create habitat for the Rio Grande silvery minnow, which has designated critical habitat in this area. Because the SWRP is providing a consistent source of water for the Rio Grande, we wanted to ensure that this restoration site benefits this species in particularly. To have a benefit for the Rio Grande silvery minnow, we first started with the question of what does the Rio Grande silvery minnow need? And we use that as our design criteria moving forward. So we know from a lot of the research that's actually performed within the collaborative program and by folks working in the collaborative program that the minnow needs a spawning period from 1 to 6 weeks from May to July. And for this, we actually set a critical threshold of 25 days of inundation in our analysis to selected design. The Rio Grande silvery minnow needs shallow and slow-moving water, so that was the other criteria that we used. Additionally, it needs winter habitat, and it's commonly found in the river with debris cover during the winter months. So that's what framed the selection of our design. To ensure our design meets our goals, we first analyzed modern flow rates and flow durations. We used that for the selection of our habitat design hydrology. And then through this whole process, we sought feedback from other folks who perform this type of work. So there's been a lot of restoration sites developed in the Albuquerque Reach, and we sought feedback on our design from folks who do this work commonly. To design a restoration site so that it achieves inundation during the desired times for the minnow spawning period, we started by considering existing sites. Existing sites typically flow at 1,500 CFS or more. In the Albuquerque Reach, they generally range from 1,500 to 2,500 for when they inundate from that May to July period. And we set a target period of inundation for 25 days. So flows that occurred for 25 days or more during that May to July period were selected for further investigation and included in our project design. So in our investigation of recent flow data, so dating back to 2007, we've actually found that flows of 1,500 CFS from that May to July period have not exceeded 12 days since 2019, and on average have been about 7 days. So it's not meeting that threshold of 25 days of inundation that we want for the Rio Grande silvery minnow, so we considered other flows at this time for our design. And we found that 900 CFS would achieve our desired function for inundation, and also retained the 1,500 CFS criteria in our further analysis due to the historic nature of this flow event. We also considered 1,000 CFS and 800 CFS in our design, but ultimately 1,500 and 900 CFS were further investigated. Once we had our selection of habitat design hydrology, which was the 900 and 1500, we confirmed that this selection of flows would achieve inundation by developing a hydrologic engineering centers river analysis system hydrologic model. So the old model was a FEMA model that was from like the 80s, and so it wasn't relevant to what were our current flows. And so we actually had to develop our own hydraulic model to see what the 1 to 100 year flow events were for this section of the river. So we analyzed typical peak flow events from the 1 year to the 100 year and fit our selected habitat design hydrology in there to ensure that they would inundate with the 1 year flow events. And as you can see, the 900 CFS and 1500 CFS are right around that 1 year flow event. So this confirms that we can move forward with these two flows in our design. From the hydrologic model confirming those two flows, we began to consider a terrace design that would incorporate these two events. And then the HEC-RAS model was used again to model and refine the design of this terrace system and adjust where the tie-ins were and this terrace system on the site. So it was an iterative modeling process to achieve the appropriate flood stage elevations and the depth and velocity that we required for the minnow. And so with the design that we selected, we were able to achieve the desired depth range of 1/2 foot to 1.6 feet and the desired velocities of 0.5 to 1.6 feet per second with this design that we selected. So that resulted in the selection of a terrace system, a single terrace that inundates at 900 cubic feet per second partially and then fully inundates at 1500 CFS. And again, this is selected because it demonstrates the desired depth and velocity, the desired duration of flow, and would occur at the 1 year flow event. Our final design balances utility constraints in the area, geomorphical context of the site itself. We actually considered an ephemeral stream to the north of our site by that Army Corps restoration site and found that the sediment management of that system just wouldn't be possible. So we excluded that from further consideration. So we had to consider those things for like the longevity of the site and what we'd be able to maintain. We also are going to be reusing materials on site. You can see the root rod revetments along the bank. This is a rendering of the site upon completion. And we'll be using the felled cottonwoods on site as part of the bank to create habitat and a mixing of the water there. And that also gives us water quality improvements. So then we have our pedestrian trail system. We'll be removing about 188 jetty jacks from the site. And then we have a really thoughtful stream bank stabilization consideration. So our design had to satisfy a lot of concerns from the Army Corps and Bureau of Reclamation regarding stream bank stabilization. So we've incorporated a lot of measures to ensure that they are satisfied with our design. The scope, let's see. And then we'll be doing a lot of invasive species removal, and we're doing revegetation on the site based on the hydrologic zones. So we'll have 4 hydrologic revegetation zones on site, and these are being defined by the frequency of inundation and the local depth to groundwater. So we've selected various species and a palette of custom seed mixes that will benefit the southwestern willow flycatcher and monarch butterfly in particular. But the zone closest, let's see, the bank to 5 feet inland is going to include sedges, rushes, horsetail, yerba mansa, some willow. And then as you move upland, we've selected other appropriate species for the area. And further upland past our terrace system, we have like saltgrass, golden currant, those type of more woody understory species. And then we want to thank everyone who participated in the project's design. The final design was actually based off a ton of feedback from a lot of various organizations and cooperating partners, which ultimately gave us a better design for our project. So, and then we'd also like to thank the state legislator who provided capital outlay funding for the design process. And then the Bureau of Reclamation and ONRT for the funding that's going to go towards construction. And the project's anticipated to be constructed August 2025. And that's all for me.
Thank you.